Okay, let's finish up division of rational expressions, but now let's put in them polynomials. And again, we know a polynomial is many monomials connected by adding and subtracting, which is going to cause a problem. How can you divide if you're connected by adding and subtracting? Well, that's easy. That just means we're going to have to do some factoring. Now, I'm going to warn you. The song says, dividing fractions easy as pie, flip the second and multiply. You first must still rewrite the expression as multiplication, and then once it's written as multiplication, you could start your factoring. So if you would just listen to the songs, they're telling you what to do. So let's go to our example on our PowerPoint. X plus 1 squared over negative 7x plus 7 divided by x squared plus 2x plus 1 over 1 minus x squared. Boy, is that not pretty. I agree. It's okay. We can work through this. The first thing we notice is we have two fractions because there are two fraction bars. And in between them is the operation of division. So I sing to myself, dividing fractions easy as pie, flip the second and multiply. That's telling me, wait a minute, I need to rewrite this first. I leave the first fraction put, I change division to multiplication, and now I take that second fraction and I do its reciprocal multiplicative inverse. So I put the 1 minus x squared in the numerator and the x squared plus 2x plus 1 in the denominator. So now that it's rewritten as multiplication, I sing to myself, multiplying fractions is no problem, top times top, bottom times bottom. Before I start to multiply, factor first, then divide. So the song is telling me, hey, you need to factor. If you look, because we have polynomial expressions, we're going to use our rules of factoring. All right, let's start with the first fraction. In the numerator is x plus 1 squared. Well, we need to rewrite that. We know that means x plus 1 times x plus 1. And that's in factored form because it's connected by multiplication. If we go to the denominator, negative 7x plus 7, now that's not factored. I said plus. What rule of factoring would I apply here? That's right, a GCF. Now, if you look, this is tricky. Do you divide by a 7 or you divide by a negative 7? The rule of thumb is if there's a negative, you should divide by a negative 7. So if I take out that negative 7 and divide, then I would get in my parentheses x minus 1. All right, I'm now going to go to my second fraction. In my numerator is 1 minus x squared. Well, there is no GCF, but that is a difference of perfect squares. So I'll put my two parentheses and I'll say 1 is 1 times 1, x squared is x times x. They're supposed to be conjugates. One gets a plus, one gets a minus. Great. I go to my denominator, x squared plus 2x plus 1. Okay, there's no GCF. It has three terms. It's obviously a trinomial. So I took my two sets of parentheses. X squared is x times x. I go to 1. The factors of 1 are 1 and 1. That's easy because 1 and 1 will add to 2. If I want to add to a positive 2, both my 1's have got to be positive. So that's why I have an x plus 1 and an x plus 1. So now my fractions are all in factored form, which means if they're connected by multiplication, I can now do division. So going back to that first fraction, in the numerator is an x plus 1 and an x plus 1. Well, if you look across diagonally, in the denominator is an x plus 1 and an x plus 1. You are dividing the same binomials, so they all cross out. If I go to my second fraction in the numerator, I have 1 plus x and 1 minus x. Now, you have to be careful. I'm looking for something it can cancel with in the denominator. The only thing left in the denominator is a negative 7 and a 1 minus x. Well, we know we're not going to touch the negative 7. So now we got to look. Is writing 1 minus x and x minus 1, is that writing the same thing? No. If you look closely, in the numerator, your 1 is positive. In your denominator, your 1 is negative. What are they to each other? Very good. They're additive inverses. But not only do the 1's have to be opposite, that means the x's have to be opposite. You know the x in the denominator is positive, so if you look in the numerator, 1 minus x, that x is negative. So we're going to cancel in the numerator 1 minus x, and in the denominator x minus 1. And because those are opposites, additive inverses, your rule is when you divide opposites, you get a negative 1. Now, where do you place the negative 1? Do you put it in the numerator or in the denominator? Well, we've already had a discussion about this. We never put a negative in a denominator. So that's why Miss Black put the negative 1 in the numerator. So now if you look closely at what you have left, in the first fraction, everything is canceled out in the top, the numerator, so we have a 1. In the denominator, still negative 7. In the second fraction, you have a negative 1 in the numerator and a 1 plus x in the numerator. Everything canceled out in the denominator, you have a 1. So now that you did all your reducing, all your dividing, we're going to multiply across. Well, 1 times negative 1 is negative 1, and negative 1 times 1 plus x is distributing. That'll give us negative 1 minus x. In the denominator, negative 7 times 1 is negative 7. But you can't leave that. You see that negative in the denominator? Where does it got to float, everybody? It's got to float to the top. Well, when it floats to the top, it floats to both expressions. You all know a negative divided by a negative is a positive. So when you float that negative, you take it off the 7 and you bring it up to the top. It goes to the negative 1. So that would be a negative negative 1, which is a positive 1. And it also goes to the negative x. So that negative would float to the top and you'd have negative negative x, which is a positive x. That's why this fraction in lowest terms is 1 plus x divided by 7. Or if you want to write x plus 1 divided by 7 in the correct order, that would be acceptable too. All right, we're going to the whiteboard to try an example. See you then.